Hi, everyone. I've just come from giving a 4-hour briefing, so I'll try to keep my voice going. So I'm the research director at O'Reilly. Probably people don't even know that O'Reilly has a research director. You probably know us mostly from our books. But we do a lot of other stuff, and O'Reilly's been kind of at the forefront of a lot of technology trends. We had the first commercial website, the first ones to do collaborative filtering. We actually sold a company in 1996 that did web work before we would have made a lot of money on it. And we honestly try to change the world by spreading the knowledge of innovators around. We're a private company, so we can invest in things like, if you're familiar with the Foo Camp, trying to bring people together to work things out. And the way that our research group works is we do a lot of quantitative analysis, which is why we're going to be talking about big data, but we also follow people like you guys. We call them alpha geeks, people who tend to be at the front lines of what's going on and what seems interesting to us. We really believe in the concept of the I can't even say it now, democratizing innovation, that the tools and everything has gotten cheaper, so more people are doing more stuff than ever before, and that's what's responsible for all that's interesting that's going on. And the future is here, it's just not evenly distributed, so we're trying to find all the different futures that make some sense to us. Really what we're trying to do is this kind of notion of pattern recognition of what's going on. We have access to a lot of innovative people. We have a great social network that really helps us a lot. And stuff like Make Magazine, where we meet a lot of people who build stuff. But we also do a lot of big data, and that is where we'll start talking about it. This is my background. I was a data warehouse guy for a while and have done a couple startups myself, and now I'm working for O'Reilly. So we have, if you're familiar with Simply Hired, which is where I met Dave McClure, because we got Simply Hired data, we have 5 years of their data. It's now about 1.3 billion rows of raw job data. And so that's our big data platform. We use Greenplum, and I want to make sure I disclose that we were Greenplum's first customer, and they gave me some stock for that, and I've been a shill on their website. So I try to be as fair as I can be, but I want to make sure everyone knows that. Whenever we see something happening, we also try to pull data from it. So we're pulling stuff from, we've got a really good Facebook app history thing. We're pulling iPhone ranks. We're about to start pulling Android app ranks. We have a Twitter stuff. So if there's data around, we try to pull it in and see if we can make some sense of it. We also recently did a big data report, and you're going to really see some of what came out of that. The first thing I want to say before we talk about data is you're all at startups. If you're thinking about data as part of your business, you want to organize to experiment. I mean, that's kind of our primary directive with all this stuff, is you don't want to go and design something that takes a long time or throw so many people on it. You really want a fast, agile, XP kind of approach where you're throwing something out, you're seeing if it works. You want to save everything. Jeff's got a great expression of it. Persist. What's your expression, Jeff?
Persist first, analyze later.
Persist first, analyze later. You want to load things up. You want to be flexible with your schemas. You want to run experiments, and when something works or something needs to be repeated, that's when you make it formal. And that's when you might go into building reusable interfaces and so forth. So what is big data? Well, big data depends on what you're used to. If you're starting with a single box and some small data sets, and suddenly things are running a lot slower than you thought, even if it's not a big number, it's big data to you. So as soon as the data starts becoming a challenge and part of your design, that's when it's big data. Why does big data matter? Well, there's more data than ever. A lot of it is this kind of web-based, right? So the web is this huge generator of data. Sensors. Social networks are full of so much interesting information, and that's a big and complicated data set. Just tracking behavior. Knowing what people are doing on your site, if you're looking at log data, you can get so much insight from that. And now public data. If you haven't been on the data.gov site, there's Sunlight Foundation, there's all sorts of new stuff coming in. And data ends up providing a great competitive advantage. If you can gain some weird insight that no one understands, right, that's a big thing. And in the information age, it might actually be the core competency of what a good business does. Google was able to figure out where the swine flu was before the CDC did, because they were able to look at their search data and see people asking about cold medicines and the local pharmacy more often than they used to before. So there's a kind of amazing insights around. And we're now into an era of a database of expectations, this kind of sense and respond. It used to be on the web, you might have put up a page or you took an order. Now, when someone's doing something, you might want a sophisticated set of things, recommendations, connections to other sites. It might trigger a whole new set of events. So there's this database of expectations. And I'm not going to talk much about intelligent systems, but data and feedback are what improves anything you're doing around machine learning. There's many businesses that are essentially data mashups now too, and I'm sure a lot of you are starting some of those. So the challenge of handling big data has come out of all this new data. When data warehousing started, when I started building data warehouse in the early 90s, you took it from an ERP system. Well, I haven't handled ERP-style data in years. I'm handling unstructured text. I'm handling metadata, tags, stuff that has really loose relationships. It's not third normal form, if you're familiar with data stuff. There's so much now. Everything needs to be geographically tagged and stuff. So with all this new kind of data, with it getting big, there's now new approaches. It's almost like a jigsaw puzzle of what you might put together. There's been, not so much now, maybe like a year ago, people were talking about, well, is this the post-relational age? And I don't think so. I think it's really augmented. There's now all sorts of ways to handle data, and you need to pick what's right for the circumstances you're facing. One thing driving everything is with so much data, you need to be able to write it fast. You might not know what you're going to do with it. You need to be flexible. So you want to have this kind of notion of a flexible schema before you figure out what's going on. And given that relational is still part of the thing, is how do you integrate those kind of things, which we actually think is going to be kind of a fundamental challenge. So what's been going on? The hardware is getting better, but it's getting better in a funny way, and I think that this is really important. 10 years ago, you would hope that your new machine ran at a faster clock speed, and so you can buy new hardware to make everything faster. Nowadays, there's no more faster clock speeds, there's more cores. With more cores, that means parallelism is what matters the most. Increased storage is just part of the game, and even though there's like bigger disks, that's going to probably end, but parallelism also helps that. And faster networks. If you're familiar with the, I forget what it's called, the Supercomputer Center at UC San Diego is putting in 10 gigabit networks, and that helps with this. Data compression has become more mainstream, and the compression that's used isn't so much for making things really small, it's just making things kind of small, but doing it fast. And then the biggest thing is distributed data and parallelism. So we think that that's like really what makes the biggest difference. When you start getting into parallelism, what starts kind of rearing its ugly head is resiliency and failing. If you had 4 servers in a cluster, you expect them to stay up. If you have 1,000 servers in your cluster, you expect them to fail. So you've got to figure out what that means for you. So there's kind of 3 fundamental approaches plus 1 orthogonal variant I'll talk about. Column-oriented is a way to compress typically integer data into a small thing. It's great if all you have is integer data. MPP, massively parallel processing, is where your data management layer handles sharding across multiple systems. It's still relational. It's still SQL on top. MapReduce, and I don't know, there might be a better name for like distributed data management, is a way of using distribution, has a lot of resiliency in it, has great programmatic interfaces and developing higher level interfaces, and a flexible data structure. I'll bring up streams in real time because we think one of the themes of the next few years is going to be real-time data. That doesn't mean everything needs to be real time, but there's more opportunities to take real time and turn it into data. And that might mean that you need to think about how to handle big streams of data and what you might do with it. And there's some companies that are handling that, and there's even some developments in Hadoop that make that more part of it. So, just looking at my time. In the parallel world, I put Teradata up there. No startup is going to go to Teradata. They're the granddaddy of parallel databases. But in the next layer, we have like companies like Greenplum and Cognitio and Aster. And I thought I had, oh yeah, okay, I've updated it. And then Teza. So these are folks who are selling databases. A lot of them are built on Postgres there. And I'll say one thing about Greenplum. So I already said my disclosure. They've just come out with a free single server version. And what's nice about that is if you're thinking about parallelism working, it might be a way to start with it. And it's free. And now with 8 core things, you get some parallelism. So if you have in the kind of 1 or 2 terabyte range, it's not unreasonable to think you can get pretty good performance. In the column-oriented databases, and this is all starting to blur some. Sybase IQ is kind of the Teradata equivalent in columns. They've been around for 10 years. And I actually worked at Sybase and used it a long time ago. But it's kind of like a single server thing where you use a SAN to go things out. Vertica and PowerXL are newer, and they have some MPP facets to them in that they're designed to be more distributed. And then in the MySQL world, there's a couple of kind of hybrids. InfoBright is kind of a unique metadata tool, and Kickfire is a proprietary box. Now, in the MapReduce world, I mean, the main thing there is Hadoop, and Hadoop is based on the Google MapReduce, Google Bigtable concepts taken out and done open source style. And the important company there is Cloudera, and Jeff is going to be able to talk some about that. When we talk to startups, we are no longer surprised at how many of them are thinking of Hadoop as their first choice of how they're going to handle any big data problems. Now, there's a couple of interesting new things that have happened with Hadoop. I talked about organizing to experiment. Hadoop DB combines Hadoop, which is kind of a key value distributed thing, with a distributed share nothing. Hopefully this isn't out of context to say share nothing. Postgres. So it's an MPP database that's mixed with it. What we like about that is you can use Hadoop for your experiments. And when you need to formalize, there's a database that you can go to. It's very immature. It was first announced in September, I think. And there's a lot still to be done with it, but it's something to keep track of. And even more recently, 3 weeks ago, HOP, which stands for Hadoop Online Processing. Hadoop was really designed around batch work. And so between the map and the reduce steps, you have to wait for tasks to finish. What this does is pipeline the work. It also adds some great resiliency to it. What it means is that as one step is working, it's already sending data to the other. If there's some kind of failure, it knows the checkpoint and can restart partway through a job. That's, like I said, is very immature. But I believe the code is going to be released in kind of a matter of weeks. In the kind of distributed data world, CouchDB is the one that gets the most press, and the whole NoSQL movement, which is really related to MapReduce as well. And there seems to be new ones that come out all the time. I actually did this a few months ago, came up with that list. I think there's probably newer ones that would replace it. And then in the stream world, the two kind of major companies are Streambase and TrueViso with it. And what these kind of do is that as data comes in, you can set a window, and you can get alerts and run SQL against them and stuff. So the key technology dimensions, what you should be looking at when you're looking at big data. The first thing is, I've mentioned parallelism a couple times. It's very important. As soon as you move to 2 servers, that's the step. Moving from 2 servers to 10 or to 100 or to 1,000, I mean, it's work, but that isn't the big deal. It's when you move to 2. You have to think about partitioning and how you might want to bring data together. And what we mean by horizontal and vertical is whether you're, probably, given the time, I'm not going to go into that. I'll be at this table and you can ask me about horizontal and vertical. Do you have an infrastructure that supports SQL? Or is having procedural logic enough, like the way MapReduce and Hadoop handles things? How detailed do your data structures need to be? Is there something about relational that helps, or a key value, is that good enough for you? Resiliency, if you're going into big numbers of nodes, you have to wonder how you're going to handle things when things fail. And then hardware, there's some of those choices had commodity hardware, and you have to decide whether you like those or not, like Kickfire and Netezza. You can't talk about data, not talk about the cloud. The cloud is great because of the quick spin out. The reason you'd want to go to the cloud is because of parallelism, but you got to be concerned about I/O. Because sometimes with the cloud stuff, the I/O isn't as fast as with other machines. But you can always get more nodes. And you get nice rebalancing with the cloud. With data transfer, and when we've thought about some cloud things, we've stopped because of how much it would cost to transfer the data into the cloud. You can ship your drives, though. And I'll tell you, we're actually doing a project right now where we're going to ship drives to Amazon. It's actually cheaper and faster sometimes to ship a drive than it is to send things over the network. And depending on the data, you have to think about security, and you might want to think about energy usage, depending on your attitude. With security, we think people are too secure. They treat data too gingerly. And quite often, things don't need to be treated as secure as they might otherwise be. So we use the job database, we analyze it. We just want to show you what's been going on the last couple of years with job posts. They've definitely been going on, been going down since the recession started. And we just want to provide some context of what we see startups are doing. So what's interesting here is the big growth in Hadoop from a small base. Continued growth in Postgres in an otherwise down market. And really interesting to us is the downgrade in MySQL. Now part of that is that MySQL was very well established. Maybe everyone assumes everyone knows it. But I think it's a lot to do with the FUD around the Oracle purchase. So, in summary on the big data stuff is, there's more data coming in. I only mentioned sensors quick, but we actually talk a lot about sensors with people. There's so much more the world is censored, and I wish I had my Android phone here. Cell phones are creating huge amounts of new data sources. Augmented reality is something that's going to happen and is part of that. With all this new data, there's new data management strategies. You have to think about what works right for you. You got to remember why you're doing this. You want to analyze. There's a whole new set of skills, and in fact, I've got a whole other end of this deck that I'm not going to really go through about the kind of new data science and how you need to integrate a lot more things than certainly when I started doing this stuff around visualization, natural language processing. Since the data is so much less structured, you're going to be using it in all sorts of different ways. Machine learning. And one of the things about machine learning is usually it needs a human to clean up what the machines aren't very good at. As we've talked to folks, the thing that we most kind of value hearing is when the culture of the company is a data-driven culture. If you talk to people at Google, where they're well-versed in what's going on with their numbers or in their area. And the best way to get there is that everyone knows that experiments are going to happen. You don't really want to deliver the big monthly report to everyone. You want people excited about the data and know that they're not just asking for data in kind of a raw form, but they're trying to get insight, and that's what you're trying to provide with the data. The other thing I'll say is the choices can be kind of befuddling. I actually don't think you can make wrong choices. It's good to do proof of concept and figure out what's going on. Most of these things you can make work if you want to do it. And I'd think about how many resources you want to spend on all this in making these kind of decisions and the kind of skills you have. I'll give one example just from my experience. I started relational databases a long time ago, and I'm pretty familiar with them. And I'm always surprised at how many developers don't really understand them. And even with the kind of abstraction layers to databases, they still don't really know what's going on underneath, what outer joins are and non-procedural logic is and stuff like that. But they do know lists of lists and dictionaries and stuff like that. So thinking about what kind of people you're going to be hiring and how they might interface with the data should probably be a factor in how you look at what tools you might want to use and how quickly you're going to get up speed with them, and then how they might integrate to how you're going to use that data in your business. So we're supposed to do 20 minutes. 20 minutes. Good timing. So I'm going to quit out of this and start Jeff's.
And actually, is there?
Oh yeah, I'm happy to take questions.
Throw out a really, really good question. Sounds like John over there has a really good question. Actually, mediocre question. All right, mediocre question.
You spent a lot of time talking about getting data, holding data, and all that good stuff. But it still seems like what you've done is we've bottlenecked into a couple people that now know all the stuff in there and how to get it out. And that seems like the constant problem is, now that you have all this great stuff sitting in that database, you didn't really talk about the tools to get it out.
So there are 8 slides or something after this where just with the time frame. Now I'm going to, oh, there you are, you moved. LinkedIn is an interesting, I think, prototype. We actually did an article about them. If you want to use the data, you need to have people to look at it. To expect that everyone in a company is going to know about the data is unrealistic. I've worked with big companies and small companies. There's very rarely more than like 5 or 10 people who really know the data. But there's plenty of people who can understand the results. So you're going to have to invest in that side of it. And that, fundamentally, what you need to do is tell stories. There's a guy I know that gives great kind of advice to giving presentations, and he uses an example. If I were to write 7 phone numbers up here and ask you to memorize them, you'd never memorize, or 6 phone numbers. But if I asked you to tell me the plot of every Star Wars movie, you could probably tell me. And they're much more complicated than a phone number is. And the reason is that we're wired for storytelling. So in thinking about what you're going to do with data is you need to weave it into a story. And examples really work with that. And this might have seemed maybe like dry and I'm treating data as just a bunch of binary bits, but when we pull stuff out, I mean, we always wrap it in a story. In fact, when I didn't say it because I was going quick through the O'Reilly part, I mean, in my little notes it says fundamentally we're storytellers. And I think if you take that approach and make sure you resource up for this, so I think you need someone with a doctorate in stats on your staff. You need someone who's, and they're usually going to know machine learning. You need natural language, unless you're not doing anything with language. So you need to understand how that works and how that might be part of what you're doing. You need visualization, and that means graphic design as well as perception analysis. People who know the data, who understand data, and people who know the business and how the data relates to the business or what you're trying to pull out of it. I think a lot of companies underinvest there, and then they end up thinking that it's not, what they have isn't very good. Or they give reports that don't tell a story.
Actually, one more question.
Sure.
Oh, we've got a couple more now. Go ahead, Gil.
So you talked about who's best at the data layer, who's best at the human factors, user interface layer?
Well, most of them rely on the tool. So anything that's SQL, so like the column and MPP databases, you just use SQL tools. I mean, I use something called Aquafold to get at it. So they don't really come with data layers. I mean, you're expected to put something on it. And there is, when it's SQL, there's a whole infrastructure that's available. When it comes to Hadoop, it's maturing and it's getting a lot better. So there's a lot more out there. So it's not like there's a company providing it, but if you follow like Cloudera, and I think Jeff, you'll probably be talking some about this, they're providing a lot of tools to make Hadoop easier to pull in. Now, if you're building, I don't know if you're talking about apps on top of it and trying to visualize what's in the database, we love ProtoViz, which is out of Stanford, Jeff here. And we're trying to aim a lot more towards JavaScript-oriented stuff. And we're lucky enough, we don't care that Canvas isn't part of IE. So, because we're not going out to a mass market, generally, when we do our work to do that. So hopefully that answers your question. And I'm happy to talk.